Good evening, everybody. Uh, Today's session is going to be on electronic navigation. The first part of this session is on GPS for powerboat level 2. This is going to be followed by a second part, which on the modern plotting devices that we typically see on powerboats. While the team live event is happening, if you click at the top right of the screen, you'll be able to ask any questions, which I will try to answer at the end of the event. The screen will go blank now while I set up the first part of the presentation. This short session will cover the basic use and limitations of GPS. What is GPS? GPS is a global navigation system, and whilst there are others, GPS is the one most commonly used in the UK. GPS stands for Global Positioning System, and it is operated by the US government. GPS listens to signals broadcast by a network of satellites in orbit around the world. By precisely measuring the time taken for a signal to arrive from a satellite and knowing its position, it is possible to calculate your position on the Earth's surface. There are many types of GPS devices, and you will need to familiarize yourself with the operation of whatever device you find on your boat. Some typical examples are shown here. On the bottom left, you can see an older handheld Garmin GPS 72, which shows position as a latitude and longitude. It has many of the core features that are required, but it does not have built-in navigational charts. Nonetheless, these type of devices can be used as the main GPS on small open boats and can act as a backup to larger devices on bigger boats. On the top right, we can see a handheld device with a plotter that shows the boat's position on a navigational chart. Like all devices with built-in charts, it is important to keep the charts up to date. On the top left, we see a full-featured plotter that will typically be found on larger boats. Also shown are GPS plotter apps for tablets and smartphones. Whilst these apps can be very powerful, care has to be taken to protect the tablet or smartphone from water damage, and battery state has to be monitored, as these apps can drain the battery very quickly. Whilst GPS will show a position to within 3 decimal places, this does not mean that they are truly that accurate. They will always produce that number of digits regardless of how accurate the figure is. A minimum of 3 satellites are required to establish a position, but the more satellites that the receiver can connect to, the more accurate the location will be. Accuracy can be affected by the number of satellites in range, the position of the antenna, damage to the antenna, overhead obstructions, weather, storing a handheld set in a container, timing errors, the sun's electromagnetic activity, and other factors including power loss. GPS sets often show information about satellites in range and how strong their signals are. However, unless you are an expert, this information may be confusing. Most modern GPS sets will have a simple display that shows the current accuracy of the position. In this example, The GPS device is currently accurate to within 15 meters. GPS devices can have many different features, but some common ones are navigational information. This normally includes charts, but can also include tidal flow and heights, harbour and marina information. It is important that this information is up to date. Waypoints and routes give the ability to choose points and join them together to form a route. Often a GPS plotter will be able to calculate the bearing and distance between waypoints as shown in this slide. GPS terms. There are some common terms that you may come across when using a GPS device. Position. This is normally given in latitude and longitude and can be plotted on a paper chart. COG, course over the ground, tells you the direction your boat is moving. This is probably different to the direction it is pointing because of wind and tide effects. SOG, speed over the ground, tells you the speed your boat is moving. This is probably different to the speed through the water because of tide and wind effects. Course, the desired course from the previous to the next waypoint. BRG, bearing, or sometimes BTW, bearing to waypoint, is the direction from your current position to the next waypoint. RNG, or range, or sometimes DTW, distance to waypoint, is the distance from your current position to the next waypoint. TTG, time to go, how long it will take to get to the next waypoint. XTE, cross-track error. This is the distance the boat has drifted to the side of the intended track. The drawing in the centre is the highway view. It looks like a road and the boat should be on the centre line. It gives a visual indication of cross-track error. In this case, the boat is 0.9 nautical miles to the starboard of its intended track. GPS limitations. GPS plotters are great tools and can make life much easier. However, they are not infallible. They may be subject to errors or fail altogether, or you may be using them incorrectly. Always sense check your route on paper chart and study the chart. It may have different information. Remember, just because it's digital doesn't mean it's perfect. As well as using GPS, it's good practice to monitor and confirm your progress with other means, such as bearings, transit, depth of water, distance and time travelled. Be especially cautious in poor weather, when other sources may not be as easy to use. A GPS plotter is not like a car sat-nav. It cannot plan a route for you. If you place a waypoint and tell the GPS to go to it, then it will point you in a direct line. In this example, going straight to waypoint 2 is a bad idea. You need to study the chart and plan a safe route. In this case, adding waypoint 1 will take you safely around the headland. Actually, some new plotters have an auto route feature that will create a route to avoid hazards, but these should be used with care and their suggested route should always be double checked. Okay, the screen will again go blank for a short while I set up the second part of this presentation.
Hello and welcome to this presentation, where we'll be taking a look at electronic navigation and particularly how we might want to look at it and use it on an RYA Powerboat Level 2 course. For those of you that don't know me, my name's Paul Brown. I'm a volunteer with the Sea Cadets as a National Boating Advisor with the Inshore Boating Team. I'm an RYA Powerboat Trainer and an RYA Yachtmaster Cruising Instructor. So what about electronic nav at Level 2? If you haven't already seen it, there's another presentation in the classroom dealing with more the basic fundamentals of GPS. So if you haven't already had a look at that, I would suggest looking at that first. My aim here is to build on that and demonstrate some of the modern plotting devices and things we typically are now seeing more and more on small powerboats, and try to show off some of the features there and do a live recorded demo, so those of you that haven't seen some of these systems can start to just get a feel for what they offer. So many boats now have these fitted, even ribs down to 4 or 5 meters in the leisure market, and as instructors the RYA are now starting to expect us to be able to teach about these devices, the benefits of them and how best to use them. And it's certainly not unknown in the commercial market that many clients will have boats with one or more of these devices on, and they will very commonly ask how best to use them, because they can be quite fiddly unless you've spent a bit of time around them. You need to know how best to use them. So if you're teaching on a boat and it has some equipment, a chart plotter or what we now call a multifunction device, one of the best things to try and do is integrate it with the pilotage planning work. So we've got a presentation on pilotage planning and passage planning in the Google Classroom as well. Obviously, we're always going to teach people the old-fashioned way, so they know what to do if all they've got is a traditional chart and a pen and paper. But in addition to that, we can actually, if they've got a suitable plotter on board, we can start to show them as well how you can transpose the information from the pilotage plan they've put together on paper into the electronic plotter on board, and demonstrate how both of those work as we execute the passage. So a key thing to remember is there are a number of different chart plotters, or MFD, multifunctional device manufacturers, and all the interfaces are slightly different. And to be absolutely honest, we're all now used to tablets and touchscreen phones. Apple and Google have spent vast amounts of money developing user interfaces that are pretty easy. The manufacturers of leisure chart plotters have a tiny fraction of that budget, and their interfaces are nothing like as easy to use. So these days you can get touch screen chart plotters as well. Some boats will have those, but a lot of them are still driven by certain numbers of keys and combinations of key presses and things. And they're all very different, even between the same manufacturer. Things have changed over the years. So whenever you get a chance, all I can say is have a play with it. Even if you've only got 5 minutes, turn the chart plotter on, press a few buttons, start to see how things work, and you'll soon start to get the idea of what the manufacturer's hoping to make you do with their system. So what's an MFD? We used to call them chart plotters. These days a lot of manufacturers call them MFD because they do a lot more than just chart plotting now. They can have a lot of other inputs. So this is, I guess, your more traditional rib console, at least from a few years ago. If you're lucky, you'd have a few engine instruments, typically something like this. You might have a little depth sounder like this to tell you how deep it is. You might have a VHF radio, and that's about it. These days, dashboards in especially the larger leisure market craft of larger ribs and things might look something more like this. So you notice here we haven't actually got any what I would call traditional engine instruments. We've just got 3 MFDs, multifunctional devices, and they can plot engine data as well from a modern CAN bus or NMEA connected engine that's all electronic. And you'll see here actually these screens are showing multiple things as well. So in this case, we've actually got a chart plotter here, the traditional chart view. They've got a radar view showing here. That could also actually be overlaid on the chart plotter as well. We've got a sonar depth sounder view here showing the bottom profile, and there may be some fish showing here. And in this case, they've chosen to have a compass or heading on this screen as well. And the different screens, as you can see, can display different things at any one time. And we're starting to see dashboards go more this way as particularly engines become more electronic. It throws away the need for the separate engine dials and makes the dashboard a little bit more customizable. And that's another example of a similar dashboard, again, all electronic, no traditional needle type gauges. And in this case, you can see they're both on chart view, but here they've got one zoomed in so the helm can see, where he's going. Presumably he's coming to anchor in here. And they've got the island as a larger view here if they want to see the general picture of where they are. So that's what modern dashboards are looking like. Clearly in the Sea Cadets, we're not quite going down there yet, but costs are actually coming down all the time. So, at some point in the future, I'm sure even within the Sea Cadets, we'll start to see chart plotters on board. So key things to think about and some of the key terms. Two different electronic chart types. We've got raster and we've got vector. So raster is very much an image of a paper chart. So if you took a photo of a paper chart, that is effectively a raster chart. You can zoom in and out, but all you do is the picture grows, nothing changes. Obviously, if you keep zooming in, it just becomes more pixelated and more pixelated until it is just, impossible to use it. It's just a simple picture of a paper chart. Vector is a lot cleverer. It's a dynamic chart. And you'll see in a minute when I give you a demo, as you zoom in and out on a vector chart, the chart plotter is adding and removing information to try and make the chart display appropriate for your current level of zoom. So in a way, that's really nice. It makes the chart clearer when you zoom out, and when you zoom in, it displays a reasonable level of detail. But the massive thing to watch out for there is, especially if you're using it to plan a passage or do your pilotage, if you zoom out too far, some critical details may get dropped off the chart, rocks, wrecks, shallow areas, things like that. So you've got to be very careful when you're using a vector chart that you have genuinely seen everything you need to see. So that might involve quite a lot of zooming and then panning around at different zooms to make sure nothing has been removed from the chart while you're looking. Waypoints, so these are random points you can put in the chart, kind of like putting a cross on a paper chart. Obviously, you could choose to align it close to a physical mark, whether that's a lateral mark or a cardinal mark or something, or you could just pick any point in the sea and you could enter that as a Latin long in your GPS, and you could plot the equivalent Latin long on your paper chart, and that is a waypoint. We'll talk a little bit about selection of waypoints in a minute. If you have multiple waypoints, you can join them together, join the dots, and you can create a route. And then your boat can then follow down that route. We'll have a look at creating a route in a minute in the demo as well. And that's kind of what we're doing at the pilotage plan. Some other terms, BTW is bearing to waypoint, DTW is distance to waypoint, and TTG is time to go. Some chart plotters will use slightly different terminology there. And once you've actually activated a waypoint, these are then showing you the directions to that waypoint. So bearing to waypoint is from your current position. What is the bearing to the selected waypoint? What is the distance to the selected waypoint? And given the current speed we're doing, what is the estimated time to travel to that waypoint? Cross-track error, XTE, is an interesting one because obviously you may not go precisely along the line between the two dots on your chart or in your chart plotter. At sea, we have wind, we have tide. That might drift you off your line if you're not watching carefully what's going on. So in this little example here, we are aiming to go up here, but actually the tide is pushing us off to starboard. So actually, in this case, what we call the cog, the course over ground, that's actually over here. So it's more like 070, not the 050 that we're actually pointing at compass heading wise. So in this case, cross-track error would start to show us how far off we're drifting from this course. So it's quite a useful feature, and it will then say in miles or in fractions of a mile, here's 0.1 of a mile, perhaps here's 0.2 of a mile. It will tell you how far you are to starboard of your line. And then on your chart plotter, obviously you can see, you know, maybe there's a rock here or something. You can start to see, you know, if you're approaching any dangers as well. So cross-track error is a very useful thing. And obviously, if you keep the cross-track error small, that means you're much closer to your line. If the cross-track error starts to get large, you're somewhere over here. SOG and COG, so that is speed over ground, course over ground. Course over ground we touched on. While the bow of your boat and your compass heading might be pointing up here, if the tide is actually pushing you to starboard, your actual course over ground, where are you really traveling in terms of the seabed, is actually up this way. So your course over ground, especially in a tidal situation, may be different to your compass course. Similarly, speed over ground, traditionally boats, you'd have a paddle wheel or a log in it, and many sailing yachts still do. And that gives you an indication of speed, but obviously tide affects the rotation of the paddle wheel. So it's not necessarily telling you how far you're going over the ground. It's telling you what we call speed through the water, how fast you're going with the water moving one way or the other as well. So SOG, speed over ground, is a very useful measure as well, and something I use all the time, as it's actually showing you how fast are you progressing towards your destination, taking everything else into account. So are you genuinely doing 20 knots towards your destination, or actually is the tide against you 5 knots and you're only doing 15 knots towards your destination? So chart plotters might also display tidal information. So the modern ones have a tidal database in them, and they might either show you simple things like what's the high and low tide times and heights at the port you're in, and they'll then do that for different ports. And some of the cleverer ones these days will actually show you tidal streams as well. So at the point in time you've got your chart plotter on and you're moving the boat, it will show you what is the tide doing in different positions right at this moment. Is it going out of Poole Harbour? How strongly is it going out? And that kind of thing. So it can be quite a useful, just quick reference as well if you want to double check your tidal information, which of course you will have checked in advance of going afloat anyway. Other things just to briefly mention, so AIS, Automatic Identification System, that's something that allows for the plotting of other vessels that are equipped with what we call an AIS transponder, a device that emits their position for other boats to track them by. And if you've got a radar on board, a plotter may be able to overlay that on the chart, and it may have what we call MARPA, a mini automatic radar plotting agent, which allows for, again, boats to be tracked via their radar return. So I was originally going to add more detail on AIS into this presentation, but it's quite a sizable subject by itself. So if it's of interest, I might add another presentation to the Google Classroom to have a little overview of AIS and the sort of information you can get there. So we normally talk about GPS, but in several of the RYA texts now, you'll start to see a reference to what we call GNSS, Global Navigation Satellite Systems. And that's because things have changed a little bit. So GPS is the one we've all heard of. It's the one originally created by the Americans and funded and maintained by the Americans. And that's obviously what a lot of us use, whether it's on our phones, in our cars, whatever. But these days, it's not the only game in town. Some people will have heard of GLONASS, which is the Russian equivalent. That's fully functioning. The latest GPS receiver I bought the other week as well supported GLONASS as well. Many of them will be able to switch between. And obviously Europeans are busy launching Galileo as well. That's not quite up to full strength yet, but the aim is that will be another satellite-based global positioning system as well. Those are the three we commonly hear of. There are actually a few more. The Chinese are developing one as well, Beidou, and the Indians have one that they're in build as well. So how accurate are they? So GPS precision is typically stated as 3 to 15 meters. Obviously, in a boat, we'd prefer it to be the 3 meters rather than the 15 meters. 15 meters could well put me, into a danger zone if it's a relatively narrow channel, but that's something we need to be aware of. If you can't just stare at your chart plotter and drive a boat, you need to use the chart plotter in conjunction with your eyes and ears to see what's going on in real life. If you want to check what the current accuracy is, most GPSs will have something called HDOP, the horizontal dilution of precision, sometimes just abbreviated to accuracy, and that will give you a number, which is a number in meters, and obviously a lower number is better. A far lower number means there's far greater precision, there's far less error there. What causes that? So similar to 3-point fixes, essentially it's to do with what's the crossing of the satellites that you're currently using to fix your position. Similar to a 3-point fix, if you've got nice intersecting angles, that's much easier to calculate an exact spot on the surface rather than if you've got very narrowly intersecting angles, the diagram on the right. So picking and using waypoints, what do we need to think about? So where you can, use visually identifiable objects. So things like buoys, lateral marks, cardinal marks, landmarks, things like castles, big buildings that are marked on the charts, anything like that. Because obviously the massive advantage then is while you're on your passage or your pilotage, you can then check that you are really in this spot. You think there should be a castle there, and yes, there is a castle there. So there's definitely no mistakes. If you're using electronic navigation and you're plotting waypoints and you're using physical points, perhaps a buoy, then shift the position very slightly, a few meters. You don't want to have your plotter driving you directly at a buoy. Maybe you're not paying full attention and you actually hit the buoy or the lateral mark. So best practice is shift it slightly away, obviously to the safe side. So if it's a lateral marker, shift it up the channel a bit, into the channel a bit. Don't shift it outside the channel onto the sandbank or the danger zone. Check for dangers and obstructions between waypoints. Obviously, we touched on before, if you're on a vector chart and you've zoomed it right out, you need to zoom right in before you start joining the dots to make sure you haven't joined two buoys together that have a sandbank between them or something like that. So be very careful to check for dangers if you're doing this on a vector electronic chart. While you're on passage, don't steer directly at a solid object. So again, in case you get distracted or whatever, don't steer directly at the middle of the nice large lateral mark. Steer slightly to one side of it, preferably the safe channel side of it, just so you make sure you can't hit it by accident. Don't rely on the chart plotter. We said before, you can't just stare at the screen and drive and assume you are within the precise millimeter that you hope the screen is demonstrating. You need to keep your eyes open at all time, keep a very good visual lookout, both for the dangers and for things like other boats around you. Obviously, if you're Wolverine, you can take a sniff and use your nose as well. What happens if the chart plotter dies? Obviously, they're reliant on electronic battery power. If the battery system on the boat goes down, or maybe the alternator on the engine's failing to charge the battery, then we need an alternative way of navigating. So on a 3-point fix, on a level 2 course, we should be teaching 3-point fixes as well. And that obviously allows us to fix our position on a paper chart and then plan where to go from there. Other alternatives, if you can see where you were and you know how to return, then you can head back to your last safe position. If that was a lateral mark half a mile behind you and it's safe to do so, then return back to that safe position. Then you're in a known place and you can potentially radio for help, and you've got a known position to give them. If you're not comfortable doing that, perhaps a really thick fog's come in and you can't actually see where your last known point was, then find a place to anchor safely, obviously not in the middle of a commercial shipping channel. Find a nice shallow area where commercial craft can't get to and safely anchor yourself and hopefully radio or phone for help. So when you turn on a marine chart plotter, all of them will show a message very similar to this, which is very discouraging. So that's just part of the manufacturer's liability. They don't want to be sued if you're relying on their chart plotter and it goes wrong. And you're simply reinforcing the sort of good practice we spoke about earlier, i.e. don't rely solely on the single source of information. Make sure you've got backup paper charts, reference materials on board, and you know how to use them. And you don't just stare at the screen and drive, you're actually keeping your eyes and ears open all the time, and you're looking at what's going on around you. So now then, let's jump into a live demo, and I'll show you one of the chart plotters I use and give you a bit of a walk around it.
Okay, so let's start then. This is actually a Windows tablet-based charting system that I use on our sailing boat, but it has all the same features as the installed devices you'd find on a rib or a powerboat, and it's just slightly easier for me to demonstrate with because I can screen record the Windows laptop. So this unit uses what we call vector charts, which are the dynamic charts that change what they show depending on your level of zoom. So here you can see obviously we're relatively well zoomed out, and we've got the entire English channel on display and not much other detail other than that. All the pink lines here are lines because this chart plotting system plugs into our sailing yacht. The pink lines are what we call the breadcrumb trails, and they show where we've been in our sailing yacht in the last couple of years. And that's a really useful feature even when you're out there navigating, because if you want to suddenly turn around and go back the way you came in, you can actually just follow your breadcrumb trail on the way back out again. So I actually find that a really useful feature. And I have the breadcrumb trails logged from the last couple of years, so I can see exactly where we've been, where we chose to anchor, and things like that. The little blue circles are waypoints. I'll come along to those as we zoom in and have a look at those in more detail later on. The little red circle up here represents my current location. I happen to be sitting at home, but I've got a GPS input to the laptop. And that then, as you zoom in again, it shows a picture of a boat. It's just turned yellow because at home it's lost GPS signal. So as we zoom in then, you'll start to see more detail appear. And suddenly we've got into enough zoom now that we're starting to see Admiralty style colours here. So white is deep water, blue is the shallower water. And here in Poole Harbour, you can start to see some green, and that is the drying heights where Poole Harbour is particularly shallow. If we keep zooming in, and I'll just jump us to Poole Harbour as well. This particular charting software uses the same colour as Admiralty, so yellow's land, green is the drying heights. And here we can see Poole Harbour obviously has an awful lot of drying height area in it, an awful lot of green with mud labelled everywhere, and it is a very muddy bottom, thankfully. So in Poole, if you do hit the bottom, it's not a major problem. And as we zoom in again, you can now start to see all the little green and red flashes here. These are all the different navigational marks and the lateral marks within Poole Harbour, and all the circles around them, they're indicating the lights. Again, if we keep zooming in, you can start to get a nice picture of the channel. And for those that watched the presentation on pilotage, the pilotage exercise I demonstrated was basically coming down this channel here, leaving Poole Quay Boathaven, which is this marina here, and coming down the channel across by, this one was Stakes Buoy, the Cardinal, across here, and then down the small ships channel here, which again here is depicted by the large lateral marks and the small red posts. Being a vector chart, you can query these things. So if you want to know what this one was, you can double click on it, and you can instantly see it's flashing a quick 9 every 15 seconds. So it's a westerly cardinal, and it tells you its name here. It's called Diver, and it's number 25 buoy in Poole Harbour. And those are the distinguishing marks you'd see on it. And if you scroll down, it'll tell you a little bit about the top mark and other useful things as well.
Just a brief word of warning as well on some of the data elements. So typically either at the top or the bottom of the screen, a chart plotter will give you certain data elements or data boxes. In this case, it's at the bottom of the screen, just above the Windows taskbar. And you can see various pieces of information being displayed there. And in this case, you might notice On the very left-hand side, underneath the yellow bar, there's one Latin long, which is labelled ship. And then more in the middle of that bottom strip, there's another Latin long. So in this case, especially if, for example, you were giving a position out to the Coast Guard in something like a Mayday, you've got two positions displayed on the screen there. Which one do we give? So in this case, the one on the left-hand side labelled ship, that is the actual location of our boat. So that is the one, you know, we want to give. The other one is what we call the cursor position. So if you're scrolling around the chart, you're looking at different places, maybe you're doing some planning, you're checking different buoys, it will real time show you the Latin long of your cursor or arrow position as well. And on this chart plotter, that is the middle position. So if you are hurriedly glancing at a GPS to grab a Latin long, make sure you read what is actually the ship's position as opposed to the cursor position. Elsewhere on that bar, we've got SOG and COG over towards the left-hand side. That is the speed and course over ground of our boat coming down from the GPS. And then further over on the right-hand side, after the second position, we've got a bearing and distance. In this case, 102 degrees and 0.24 nautical miles. And that is the bearing and distance of the cursor from the current boat position. So again, if you quickly want to just do a bit of measuring rather than using the dividers, you can actually just hover your cursor over something and that will instantly tell you what course it is and what distance it is from your current GPS position.
Assuming you've got a live GPS position, then the chart will show your boat position as well. In this case, I'm just up here in the north, and you can typically click something to have the boat centered and to follow on the boat. So as the boat moves, the chart will follow you as well, and you can see in real time where you are. In this case, I'm actually sitting at home, so the GPS position is a bit of a lie, but we're just at the edge of this little area that's called Blue Lagoon. In terms of planning, it's quite easy to use the electronic charts for planning as well, especially if it's a computer-based one. So if I wanted to measure distances and bearings, you've got an electronic equivalent of dividers and a Portland plotter, and I can just simply click and it will instantly then tell me from where I start what's the bearing and distance to where I want to go to. And I can build up a little bit if I want to check how far it is to get round and into Parkston Yacht Club. I can just build up a little route like that, and the entire distance to get to Parkston Yacht Club is then displayed, and I can see each of the legs of the course. And that's just a very quick way of doing some easy measuring. If you wanted to actually plot a course, chart plotters will have what's called a routing feature, and you can then start to build up a route. So if this was actually my boat sitting here in Blue Lagoon, I could use the create route feature. And similar to the electronic dividers, I can sit here and each time I click it then drops a waypoint. I could work my way out of here into the main channel, and then I could start working my way along. And it gives me the distance and bearing for each individual leg from waypoint to waypoint, and the overall distance of the route as well at the bottom. And then when I'm done, I can say, right, there's my route. Then it tells me the total length of the route is 0.92 miles, and the first leg, the first piece I'm going to do is 0.24 of a mile, and I need to head off on a compass course of 192 degrees. What you can then do is actually what's called activate the route. And then you see over on the right-hand side, depending on the chart plotter, it may be up the top, it gives you this handy set of boxes. And if we were actually moving down the route, then you'd see the boat start to move down the course. And this set of boxes, it tells us what's going on with our route. So XTE stands for cross-track error. And that is telling us where we are in relation to our line. So our route is the red line. Ideally, we would go directly down that line. That's the line we've chosen to go down. If the wind or tide starts to drift us either to the starboard or to the port of that line, cross-track error is telling us how far distance-wise we are off our track and how far we need to go to get back on track. So that's a very useful measure to say how far in fractions of a mile are you off the line you intended to do. So if there is, for an example, a danger over here on the port side of the track as we head down, we can start to measure that if we go more than whatever distance to port of our track, we know we need to head back to starboard and get on the planned course. Bearing is the bearing to the next waypoint, so we can then check that on our steering compass or handheld compass as well to keep us on track. VMG stands for velocity made good, so that's the actual speed we're progressing towards the buoy at. If we're heading slightly in the wrong direction, then we're not necessarily using up all of our speed over ground heading towards the buoy. We're heading off on a bit of a tangent. So that tells us how fast we're actually heading towards the buoy. At the moment it's blank because I'm sitting at home, so I have no speed over ground, no velocity. Range is the distance to bearing or distance to waypoint, sometimes called DTW, and in this case it's 0.28 of a nautical mile. TTG, time to go. Again, if we were actually moving and we had a speed input, that would then calculate speed, well, time equals distance over speed, and it would be giving us a live reading of how long is it expected to take to get to the next leg, the next waypoint. So those are fairly useful things that you can then just glance at and see how are you doing on your course. Are you actually on the course you intended to be? How far off the course are you? How long is it till the next waypoint? And just very easy to glance at and see what's going on. If we were, I can then delete the route and get rid of it. We talked a little bit before in the presentation. You can also just choose to drop waypoints. So if you wanted to start plotting a route slightly more manually, we could drop a waypoint here, and then we can position it where we want it to be. And we said before, if you are dropping a waypoint to steer on the correct side of a channel, it's best practice, don't drop it directly on top of a lateral mark or an actual physical mark, because we don't want to accidentally get distracted and be steering directly onto a solid object. So you're best to have it slightly away from the physical mark, but obviously on the safe side, I'm not going to drop it here onto the sandbank. I don't want to go over the sandbank, but if I just come up here a little bit, then I know I can steer that course and be completely safe. And you could then choose to drop multiple marks. It's getting confused where I've got too many routes in here. You could then drop multiple marks, and again I'll move that one to a nice safe place. And you can then go back into a routing menu and you could join up these waypoints and create a route that way. Or you could simply say, let's right click and let's navigate to this waypoint, and it will give you the instant route to that waypoint, and again show us all the cross-track errors, time to goes and things like that.
And just to demonstrate the massive disadvantage and issue with vector charts, we'll just zoom down to the West Country a little bit where there's a reasonable example that I happen to have come across in the past, which I think very nicely illustrates the care you need to take when you're using a vector chart, especially to do any pilotage and passage planning, to make sure you don't miss out on any dangers. So here we're just heading towards Falmouth and the Helford River. And if we just zoom in a bit, I'll show you what the particular problem here was. So we were anchored up in the Helford River over on the left, the little blue line there, and we were planning to go up north round into Falmouth Harbour. And as we look going around that corner at this level of zoom, it all looks relatively clear. There's a green mark there. We'll just follow close to that and head up north. But if we zoom further in, and I'll just bring the chart across again, you notice actually by that green lateral mark, there's a green drying height, the August Rock, which wasn't visible when we were zoomed out a lot more, and actually is obviously a danger that you need to avoid. So we were going very close to the green mark and we were fine, but we could see just inshore of us this rock that if we had been maybe 10 meters further over, we would have hit it. And certainly the chart plotter at the helm of the sailing yacht hadn't shown that at all. and we were just a bit surprised to be sailing past that. So another word of warning on that if you're using a vector chart, you really do have to be very careful. Okay, so how can you practice then? So the RYA used to issue a training plotter to their training centres, particularly those teaching the shore-based courses, things like Day Skipper and Yachtmaster. It's now discontinued back in 2019, but if you've got an RYA training centre friendly and close to hand that might have some of the discs, then see if you can get hold of them, and it's just a useful aid which has all the features and you can play around with it at home. If you've got a modern smartphone or a tablet, then Navionics is one of the more popular plotting apps, chart plotting apps. It's not particularly expensive. You can download it and have a play if you want to. And again, if you do teach out at the sea, it's useful to have on your phone as a backup anyway, should you need to have a look at a second chart. If you're on any boats, we said before, just have a play. All the devices and manufacturers do slightly different things. So whenever you have a spare few minutes, turn the chart plotter on and just familiarize yourself with that device, and you'll find you start to learn what each manufacturer does and how they intend you to use things. Finally, we've put a quiz in the Google Classroom as well to test your knowledge. Go and have a go and see how you do. Thank you.
Okay, the screen will go blank again for a short while we finish up. Okay, if you have any questions, I've answered a couple whilst it's been going on. Please use the space at the right of the screen, or there is an option in the Google Classroom to actually send messages, and we can answer the questions then. Follow-up classes, as mentioned at the end of that last presentation, there are some follow-up classes and exercises, and they can actually be found on the Google Classroom. A copy of this webinar will also be available on the Google Classroom, and in order to gain access to the Google Classroom, you will need the code Yankee Mike Delta Lima 6 Uniform 4. I will repeat, the access code for the Google Classroom is Yankee Mike Delta Lima 6 Uniform 4. It's important that we get feedback for these presentations, and in order to do that, if you would like to scan the QR code and provide some feedback, that would be most appreciated. And also, as I said, in the Google Classroom, there are options for you to actually ask questions in there. Thank you very much for listening.